All right, so we got some friends out for different reasons, vacations and such, so we got to record. So if you're at home, please follow along what we write, you write. So today's lesson title is going to be fraction, decimal, percent conversion. Before we dive in, as you head your notes with at least a date, please read what's up there about I need your tests turned in today. Yeah, if somehow like now you're at home and you have a test that you owe me, please email me or something about how I might be able to get that from you. You'll get them all back Wednesday. You guys are only here this week, today and Wednesday, right? You guys only have 2 school days this week. So I need your tests today so I can grade them through today, tomorrow, and get them back to you on Wednesday, right? I figure it will be easier to just give you both tests back together, so you will get them back together. I'm done grading the tests from Unit 1. I'm deciding whether I'm going to put like P or M or whatever on them, or if you're going to decide that, like if we're going to do that together. Our next unit test is going to be next week, probably, because we'll likely be ready to take at least like a small test. Guys, if we look at the calendar, I don't know if I can get the calendar to pop up on that screen. Yeah, I don't think I can I? Here we go. So these days, Phoenix is closed because there's no water. So those are our discovery days, right? Then it's Thanksgiving and we're off. So like we have 2 weeks of school. You guys have 5 days of school left before Thanksgiving break. So that's why we probably got to take another test right here, like the 18th, 19th, 20th, something like that. You guys will have school that Friday. So not sure if we'll do like a special day or what. But yeah, those are all the announcements. Any questions on announcements? Let's head our paper converting fractions, decimals, and percents. We haven't taken notes like this, I feel like, in a little while.
What's your favorite color?
Oh, well, I just grabbed purple.
There's too many colors. Did you know the Jeopardy guy died on Sunday?
Can you at least remember his name if we're going to talk about him?
I think it's like Alex Trebek.
It was. Alex Trebek passed away. That is sad. The host of Jeopardy.
Yeah. It was.
All right, so converting fractions, decimals, and percents. Let's zoom this out a little bit. Sorry, I'm going to need to leave a pen or something in the picture so it stops freaking out. So who can tell me what the word percent means? Because often people talk about percents and we don't really know what they are. Actually, just go ahead and shout it out, and then since we got so many.
100.
Out of 100. So percent, the first thing that we're going to want to know as we take our notes is the word percent literally means out of 100 or over 100, a lot of people like to say. So out of 100. So when we have these problems, and I have one before we get to percents, but we really want to think about getting our fractions to out of 100 or some sort of common denominator. But if we have percents, 100 would be an easier common denominator. So a lot of us miss this problem involving 1.3, 5/4, and 1 and 8/25. So I wanted us to look at this, even though some of us have it right now. And the announcement that I forgot to say from the start slide is that your questions will not repeat themselves this time. Sorry, I think I need to come a little closer to the paper so it stops freaking out. So these homework sets, I think some of us have been playing the game of if I do it a couple times, I can figure out what the answer is supposed to be, and I haven't really figured out the math. These last homework sets in Con, it will not repeat questions. So please try to do your best and come ask questions when you get confused, because it won't repeat the same questions for you when you do it again. So if we think about 1.3, can anyone tell me how I say 1.3 more appropriately? Just go ahead and shout it out. 1 and 3/10. So I could write that as 1 and 3/10, or I could even write it as 1 and something over 100. right? What if I want to write something over 100? What do I do then?
Doesn't that make it 30?
Yeah, to the denominator, we say what multiplication. We can't add, right? That's not a legal move, but what multiplication did we do? We did times 10. So we do times 10 to the numerator to get that 1 and 30 100ths. So then 5/4. Well, okay, since I'm already working mixed number, right, I should either decide, do I want everything improper or everything mixed? I got some people that I'm not quite sure if we're writing notes. I'm going to walk around here in a minute, and I don't want to see blank papers. So if I make this mixed, it's going to be 1 and something. I'm going to drag this up a little bit more. Right, because 5/4, 5 is bigger than 4. 1 and what's left over? Nate?
Wait.
When we go to mixed, we keep that denominator for a minute.
Wait.
Lacey?
1 and 1/4.
1 and 1/4.
Or 1 and 25 over 100.
Ooh, or I can convert this to a denominator of 100.
That's what I was about
Thinking
to say.
about, 1/4 is really 25 hundredths. So, okay, we know 30 hundredths will be more than 25 hundredths. So right now, this first number is bigger. But then 1 and 8 25ths. Well, okay, we can convert that just like we did everything else. What do I do to that denominator of 25 to turn it into 100?
Multiply by 4.
Times 4. Now remember, we're just doing that to the fraction. The 1 is staying the same. So 8 times 4, 8, 16, 32. Ooh, so this is actually our biggest, right? So here we have our largest is the 1 and 8 25ths. Our second biggest and our smallest. All right, so if we say largest, middle, and smallest. Questions on how we can compare using mixed numbers that we converted everything to. In each of these situations, we're probably going to choose something different to have be the common thing here. So what we did here was we decided to make everything mixed, right? So what we did here was we made everything common by making it mixed numbers. And then we did common denominators of 100. Any questions on that one? So now I think the next one is the negatives. No, not yet. This next one dealt with sevenths, which, guys, some of the tricks with converting these is if you can remember what one of the value is, then if I have 2 sevenths or 3 sevenths or 4 sevenths, sometimes I can more easily like convert up to the next one. The sevenths aren't really like, it's really hard because the sevenths repeat. So if you guys don't remember what we talked about with the sevenths, well, actually I should ask, does anybody remember what we talked about with the sevenths? There's kind of a cool repetition that happens.
When did we talk about this?
A while ago. Oh, we maybe haven't. Maybe it was Math 8.
Yeah, we haven't talked about stuff.
Check this out. 1/7. I want to unveil it slowly. Has a bunch of stuff repeating. What is 7 times 2?
14.
Go ahead and write this down with me if you would. What is 7 times 4? 28. Martin, we going to write this down with me, man? At what point was your pencil on the ground going to become a problem? When I asked you about it? And then what's 28 doubled? 56. Ah, crap, it falls apart there. But it was almost perfect. So guys, the sevenths are this really cool pattern. Because watch what happens with 2 sevenths. This bar, remember this bar means we repeat. And literally the numbers that repeat when you do 1 divided by 7 are 0.142857, 142857, 142857. Not joking. 0.14285714. That 3 is a lie. It's rounded. Remember, it rounds the final number. So 2 sevenths, here's something even more wild. We shift to the next highest number. So in this set of numbers, what would be the next highest number to start with? If we started at 1 here, what's the next biggest number?
8.
We got a 2, don't we? The next highest, not the highest, the next highest from 1 is 2. So now we start at 0.285714. I can't make this up. Remember, the last number on the calculator is a lie. Don't trust that. 3 sevenths. What is the next highest up digit that we could start with? 4, right? So if we start with the 4, then it's going to be 4, 28, 57, and we still got to put that 1 on. This just keeps happening. So what would 4 sevenths be? What would 5 sevenths be? Take a moment and try to write these down on your own. This pattern keeps going, and this is why I often say math is beautiful. Because, guys, this is super cool. While you take a moment to write those down on your own, I'm just taking a little walk to see that we're all writing notes, and I got to turn this up because we're all in here now. So if we already used the 4, what's the next highest up number?
5.
The 5. So our next decimal that repeats is going to start on the 5. Lucianne, I should have told you that you can move. Can you see from there?
Yeah.
Okay, just making sure. I thought those desks were okay.
5, 7, 1, 4,
Yeah. So then we start at the 5, and we'll go 5, 7, 1, and loop back to the beginning. So 0.571248. The numbers always stay in. Crap. Dang. I wrote them wrong. I said it right, but I wrote it wrong. 0.571428. Because it's 57, 14, 28, right? The numbers always stay in the same order. I have whiteout. I just never use it. What's the next highest up number that I could use?
7.
7. So 0.7.
8.
Ooh.
1.
1428, right? 71425. And the last one here, 6 sevenths. What's
8.
Yeah, the biggest number that we have in that set. So what comes after 8? Well, I can go back up to the beginning to check. Yeah, the 57. And guys, this is what I mean about keeping your notes. If you keep this handy, you can reference back to this page of the sevenths. And like, if I let you use your notes on the test, you can reference back to this page to say, well, what is, like, if I'm comparing a seventh against other numbers, what do I get? Now, so 1 7th. This is really the number that we were working with versus 0.2 versus 3/9. Now, can anyone tell me another way to think about 3/9?
1/3.
1/3. Now, do we remember anything special about 1/3 when it converts to a decimal, since it looks like we're going to work in decimals for this problem? Anyone know anything special about the thirds? A lot of people will round and tell you, oh, a third is about 30%. That's wrong. A third is about 33%, but that's still wrong. It's 0.3 repeating forever. So we could just write (0.3). All we need is 1/3. Or if you started doing long division and you got a 3, got another 3, got another 3, and you're like, oh, we repeat. You could put your repetend over the last one. You could put your repetend over all of them. It doesn't make a difference. The 3 repeats forever. Now, this is where it's weird that a calculator sometimes lies. This won't lie here because there's no need to round up. But 2/3 is 0.6 repeating forever, and the calculator lies to you because it rounds. So, hold up, we've got 0.2, 0.142857, and 0.3. All we really need to do here is compare the tenths places, right? If we're trying to order them, we've got 2 in the tenths place, 3 in the tenths place, and a 1 in the tenths place. We can actually really just order these pretty easily, right? So then if we're trying to match with the correct point, we can just say, well, if 0.1 or 1/7 is the lowest, then the lowest number here is going to be A, right? If 2/10 was the next biggest number, well, yeah, we can't, sorry, we have to click on these and switch them around and see what they say. So actually, this number line's a bad example for here, because C is in the wrong, or what's that say? 1, no, that is 1/4, never mind. So I think in Con, you clicked on the dot and it like popped up options, or you clicked right here and it popped up options. You just have to like order by selecting the right option. So remember, this is not saying that A is 0.2 and B is 1/7 and C is 3/9. That's not what that's saying. It's saying we have to fix this. What we found out, which is more important, which is why I'm going to cover everything else up, 1/7 is 0.14287 repeating. 2/10 we can just leave as 2/10, and 1/3 or 3/9 is 0.3 repeating. Guys, a lot of us missed that one, like 10, maybe 16 of us, something like that, like out of the 20-some in this class period. Does anyone have questions on that sort of problem or that problem specifically? Another one that was missed big time is this one that we're going to do next. We're going to convert everything to percents, since we haven't done one like that. So for in your notes, what did we do here? We left everything as, were we mixed numbers? Are these mixed numbers?
No.
Guys, should we all stand up for class? I feel like we're awake, like asleep today. Should we all just stand up for class? Should we do some jumping jacks? Like, do whatever you... Are you... I ask people to stand up and Stella almost gets injured. Like, that is my luck. They're like, okay, guys, let's just stand up. Student breaks face.
Yeah.
Mr. Hudson gets in trouble for somehow injuring a student. All right, do whatever you need to do to wake up. I need you to participate. Why else are you coming to school? If you're going to sit here and just stare at me like you're watching a video, why are we in class together? What type of numbers are these, guys? Decimals, right? So up here, we made everything common by making mixed numbers. So here, our common that we converted everything to was decimals, right? So we started with some fractions and a decimal, but we decided to make everything decimals. Questions? So now the common thing we're going to do is make percents. It's almost like I thought this out. So now our next problem was this one that a lot of us missed. So please write it down, even if you got it right now. I want to make sure that you understand how you got it right now. Because like I said, from looking at the data, I think some of us have just learned kind of how to play the game when I make the questions repeat themselves. So we're going to common everything percent this time. So I'm going to go ahead and off to the side, write common percent. And I'm actually going to put the hyphen in the middle of the word percent. Because what does percent mean again? Per 100, out of 100. So guys, the first thing I'm going to do is nothing with this fraction. So please drop that fraction down. Anytime we see a percent, and here's my trick. Please look up at the screen for a second. Where's my Post-its? Check it. The percent sign. Here's a little visual trick that may or may not help. One line, two circles, right? What it actually does is makes a line with two circles under it. Now really, there's also a 1 right there. So if you want to imagine, a kid once said, well, imagine just splitting that line. Part of it goes here, part of it goes through your 1. Either way, whatever comes before, really whatever is up here, goes over 100. So here's the problem. 162.5%, I think this is where kids had issues, is 162.5 over 100, which is what we call a complex fraction. It's a fraction that involves a decimal or another fraction inside of it. It's like if a fraction has a fraction in it, that's a complex fraction. Can anyone tell me what we want to do with this fraction to get rid of having a decimal in it? How could I bump this decimal to be on the right side of the 5 as opposed to the left side of the 5? Stella? Am I allowed to just grab a decimal and push it to the right?
No.
Kind of.
Sure, out of 1,000.
Ah, I can if I do it to both. Because remember, 100 actually has a decimal right here. So to this fraction, what we're actually going to do is multiply by 10 on top and bottom, which remember, it's your favorite. It's the giant 1. You guys didn't really learn about this because I know, I'm sorry, it looks bad now. But so we used to make a giant 1. I'm not even going to draw it because it doesn't matter. But if you multiply by the same thing on top and bottom, it's just like multiplying by 1. So if we have 79/40 minus 100, no, not 100 now. 1,625 over 1,000. Now wait a minute. I said the common thing we were going to do here is percent, but the route that we just took us fraction.
Great.
Because you can solve this problem. Once you get to common denominator territory, hopefully you can solve this problem. But I'm not going to it for a moment. I'm going to stop, come back up here, and actually solve this percent style. We're going to do both, but I want to show you percent style. So here is percent style. What we would do is look at 79/40 and say, how can I get this over 100? Because we said percent wants to be over, right, quote unquote, over 100. So what do I do to 40? Remember, we can't add. We're not allowed to add or subtract. We can only multiply or divide. What do I do to 40 to get it into 100? If I don't know how to go forwards, just figure out how to go backwards. So guys, if I don't know how to go from 40 into 100, do 100 divided by 40 to go backwards. the backwards of multiplication is division. So if I go backwards, I get 2.5. What's up?
Yeah, I was going to say 2 and 5 times.
Yeah, thank you very much. So we get 2.5, because think about it. If I double 40, I would get 80. Now, you could also just play with multiplication in your calculator. You could say like 40 times 2, 40 times 3. Oh, crap, that didn't work. So 40 times, crud, 2.5. There it is. So we have to do the same on top. Now, still, I'm using a calculator. I'm not saying that you could do this without a calculator. So, I mean, all of you should have a calculator either on your phone or like I like the handheld calculators like this. So if we do 79 times 2.5 to do the same thing that we did on bottom, we get 197.5.
So we technically have to do this.
Which tells me, since we're over 100, that is 197.5%. Anything over 100 is a percent. So I could rewrite our original problem, replacing this, can't get the cap off my pen, replacing this fraction with this percent, because we now know that those are equivalent values. So rewrite the problem, but instead of saying 79/40ths, we're going to say 197.5% minus 162.5%. This is the same problem. I just replaced 79/40ths with my percent value. Sorry, I like to make my ones a bit more definitive. And then I can really just do 97.5 minus 62.5. Because the hundreds will subtract from each other. Because 100 minus 100, well, that's gone. So the 0.5s will subtract from each other, and those will be gone. So what's 67 taken away from, or sorry, 62 taken away from 97? Just shout it out.
25%.
What? Oh.
35%. Now, if we come back over here, though, to the fraction side of things, what we're wondering is how do I turn this 40 into 1,000? Right? How do I rewrite this fraction? Well, very similar to over here where we did times 2.5
It would be 25.
times 25. So if I multiply the 40 by 25, I have to do the same on top to keep the fraction the same number. Right, so times 25 on bottom times 25 on top.
It would be 1,975.
Yeah, it's going to be this number, but with the decimal shifted. So it's 1,975 minus 1,625. And instead of getting 35%,
It would be 350 over 1,000.
yeah, we'll get 350 over 1,000. Which is not in percent form because it's not over 100. So at the end, we would then get rid of these zeros because anytime you have stacked zeros, we can just get rid of them. And we would get 35 over 100, which is 35%. Questions on that problem, either method that we solved it? I washed my masks and the nose thing gets goofed up. Any questions from that? Now that we talked about the sevenths, we should be able to deal with problems like this. Now that you can go reference your notes, that 4/7 is actually a value of 0.571428. So this, because it has numbers after the 57, is bigger than the 0.57, right? So 4/7 is bigger than 0.57 because it's actually 0.571428. Eighths. I wanted to talk. Well, we can talk thirds and eighths.
We already did thirds.
Yeah, but not an improper amount of thirds.
Oh.
So I appreciate you keeping me on track that we already did thirds. Yeah, we'll probably squiggly this whole thing. All right, squiggly line. Well, if you want. I don't know if you squiggly line or what you do. But another example of, I mean, just converting numbers. Guys,
6 repeated.
yeah, this is improper, right? So if we want to think about what the decimal form is, because sometimes decimal is easier to compare, or common denominator, right? But up here, one of them's in decimal. We've got an 8 in the denominator. That's kind of tough. Sorry that my camera keeps going in and out. Maybe this will help. So 7/3, how many 3's are in 7? Well, 2. Carry the negative, so 2. What's left over?
6 repeated.
Ooh, hold on. 1/3 is left over, so be careful. It's not 2.6 repeating.
Oh, it's 2.3.
Yeah, it's negative 2.3 repeating. Eighths. Here's just a note that is not like the problem. How does 1/8 compare to 1/4? Yeah, an eighth is smaller, right? If we think about a pizza, like,
They're smaller pieces.
how does an eighth of the pizza compare to a fourth of the pizza?
It's half the size.
Yeah, it's half the size of it. So if 1/4 is 0.25, every eighth, something worth learning, something worth memorizing, is 0.125. Every eighth is 0.125. So if you have negative 2 and 5/8, like we do in that problem, think about it like this. All right, guys, I'm going to ignore the negative for a minute. 2 and 5/8 is 2 and 4/8 and another eighth, right? I said I'm ignoring the negative for a minute. Ignore the negative for a minute. And we're just going to look at the 2 and 5/8. Does anyone have questions with how I broke up 2 and 5/8 to 4/8 and one more eighth? 4/8 is a half, right? 4/8 is a half. What decimal is a half? 0.5. Right? A half is 0.5. And then we just said an eighth is 0.125. Now, of course, if you have a calculator, you can use your calculator to help with this. But that tells us that this is really we'll add these up. I can add zeros after this, so this is really like 500 plus 125. 0.625. Make sure you bring the negative with you. And then our other number there was already in decimal form. I want to talk about tax problems, because that's exactly what we're about to get into. So I would like you to either start a new page of notes or draw a squiggly line, and we're going to start a new section. We're going to call it percent problems. You guys should take lots of graph paper when you take graph paper from me, so you have it when you do your Khan Academy work. Because remember, we should be writing down. Guys, it's very hard to do the work in Khan Academy if you're not writing down the work. So guys, we're going to pick a standard tax here for while we do this, just to make our life easy. But that's not always what your tax is, because it depends on where you are. Did you know there's a better choice, Easton versus Polaris? I'm going to let you, if you're interested, look it up on your own. But Easton and Polaris, you guys know what Easton and Polaris are, right? They're malls, right? They're shopping centers, which you probably don't go to as much right now.
I went there yesterday.
But guys, one of them has a higher tax rate than the other one. One of them will charge you more for the same thing because their tax is higher. But for us, let's say tax is, just for example's sake, right? For example's sake, 7.5%. Have you guys seen that as a common tax rate they give you?
Yeah, no.
So let's say tax is 7.5%. If you go and buy a video game for $50, please write this down so when you look back at your notes, you know what we were doing. You might think like, man, like, I don't know how to figure out the tax on that. I don't have a calculator with me. I got to know if I have enough money. $50 may not be that easy to work with, but it's really close to, well, not really close to, but it can easily be turned into 100, right? And we said 7.5%. What does percent mean? Out of 100 or per 100. So 7.5% means out of every 100 that you spend, the tax you'll spend will be $7.50. So what 7.5% or any tax rate that they tell you actually means is whatever the tax rate is, it is that much for every $100. Yeah.
Can I say with what the tax for the video game is?
Yeah, sure.
$3.75.
How'd you figure that out?
I split $7.50 in half.
Yeah, so if it's $7.50 for every 100, then for 50, if we split in half, we would split in half. And Lacey, you said this is what?
It's $3.75.
$3.75. Sorry, my brain started making a 7 over there. That's a 3. $3.75 for each 50. Now, here's how we can do the math, though. Like, how do we calculate it? To calculate tax, we first have to convert the percent into rate. So guys, please, I know some of you are not taking notes. Please pick that pencil back up. We want to convert the percent into rate, which really just means the decimal form. So, guys, our percent, and sorry, I'm trying to squeeze stuff in the time that we still have left, which is like 5 minutes. Our percent is 7.5%, which we said means 7.5 over 100. Now, like a few minutes ago, we said, well, we don't like a decimal in the fraction, so what could we do?
75 over 1,000.
Yeah, times them both by 10, right? So we did times 10 up here, and we're going to do times 10 down here. and get 75 thousandths, which when we write as a decimal is 75 thousandths, because tenths place, hundredths place, thousandths place. If you need to remind yourself that this is the thousandths place, the trick you can use is the amount of zeros on bottom tells you how many places should be used. So we had to add a 0 in front of here to use all those places. Right, so 0.075, 3 decimal places. So now that we've got our rate, this is our rate. 0.075 is our rate. Now we can actually just multiply. So it's the rate times the original amount, right? So we can do, our tax will be 0.075 times, how much was the video game? 50. And that in a calculator will come out to give us 3.75. Now the other way that we could do this, sorry to give you options, but that's why we write these down, right? So you don't have to keep it all in your head, is if you wanted to use your 7.5 like percent amount, and we do this multiplication, we would get 375. So if we just use the percent here, we would have to divide by 100 at the end. And here's why, guys. We have to divide by 100 somewhere. This 0.075, we did the division by 100 up here, right? We did the division by 100. We set it up, solved it, made it the decimal. Here, at the 7.5, we did not do the division by 100 yet. So that's why we still have to do the division by 100. Now we're out of time, but Wednesday we're going to talk about problems where they give us like the amount that we paid after tax. Now hold up really quickly if you want like a little sneak peek of that. If the tax is 7.5%, what we paid after tax is 107.5% of the original, or of the price. Now, if you're struggling on anything in Khan Academy, please use the help videos and the help steps, or email it to me. I've not gotten very many emails recently. I think I'm caught up. So if I missed your email, please let me know. Like if you sent me an email and I did not respond. Did you have another question?
Oh no, I was just gonna say the tax is so weird. Like, why don't they include the tax on like the price on the like price tag?
So the reason for that is certain items are taxed and certain items aren't, and certain items are taxed at certain rates. So actually, because tax comes from the government, certain things have a higher tax rate because the government says this is extra dangerous and we're going to tax it a little extra more. So like tanning, if you go to a tanning salon, their tax rates are higher because it's called a sin tax, way back from all of government like being tied up with religion. But like tobacco and alcohol, I think those also have sin taxes. Now, for things like that, it already is wrapped up in the price. So the tanning, well, it depends on how the tanning salon would operate. But yeah, some things are already taxed. Other things don't ever get taxed, like food. If you go to the grocery store and buy like milk or eggs or bread, that is not taxed. But if you go there and buy like a hair product, that is taxed. So if you look at your parents' grocery store receipt, it will be broken up into what gets taxed and what doesn't get taxed. It's really weird. So yes, you are right, tax is really weird.
You talk so fast. I've never written so fast in my life.
Well, that's why I record it and I write it, and I need to upload all the notes, but I got it written down.